you all?
No.
Oh,
We didn't talk about that.
oh, did we talk about Turner syndrome?
No, let's talk
Oh
about
gosh, we talked about this. Down syndrome. Okay. Turner's, well, let's go start with Klinefelter's. All right. On Down syndrome, what happens is your chromosome 21 has non-disjunction. I wonder if there's a non-disjunction on one of your X or your Y. Does that ever happen? Yes, it does. Sometimes it happens and you end up with somebody that's got XXY. Okay? You will need to know that XXY is called Klinefelter syndrome. Let me end this show so I can show you some pictures. People that have Klinefelter syndrome, XXY, they are male, and this is how that's their karyotype. And notice what happens is, right there, you have two X's and a Y. They are males, but their testes are small and the man is sterile. They have some breast enlargement and other female body characteristics because of that extra X that they have. They may have subnormal intelligence, but here again too, a lot of times that may not even be noticeable because, you know, really, so many people don't live up to their potential. You know, most of the time the problem is not that our IQ's not high enough. You know what the problem is? Is we're not, dry. We're not using what we have. You know, like sometimes, and of course it's nobody in this room. Actually, sometimes some of the people that don't understand what I'm going over, you know what they're doing while I'm talking? They're on the phone. They're sitting there texting. Now, is that a lack of intelligence why they can't get that, or a lack of paying attention? You know what I'm saying? So you're right. It kind of goes back to drive to want to get it. So I'm saying sometimes these people, we wouldn't even notice. It's not like they're total idiots or whatever like that. It's just that they actually, if they were really trying hard, then they still might have a little bit of trouble. But I think what I'd like to do, and I did this one time, and I just wasn't good about how to get it on this multiple choice. But I'd like to put some of these on the test because I think that would be cool, just the karyotypes. Because that's easy to see right there. See, it looks normal. See how they look normal to that? Okay, let me show you some pictures. They're usually taller, slightly feminized physique. See, mildly impaired, so that's not bad. Tendency to lose chest hairs. And then they have the hair typical like of the females. They have more osteoporosis of paretic bones, just more like females. A poor beard growth. And let's see, some other stuff we can see. This is something, now that person looks kind of more like a girl, obviously, because most of the time they're not that obvious. I don't know what that is. Okay, we're going to get to Turner's in a minute. Okay, let me tell you this. So this one right here is XXY. This is showing you Klinefelter's. My son told me that a lot of times there's a lot more people with Klinefelters walking around than we realize, or than I realize, because I think it's like pretty odd, pretty rare. He said that when you work in the emergency room, a lot of times when people come in, that when you see a person, they may not come in for something related to Klinefelters, but they just come in for some whatever. And he said automatically, if you've seen people with it and you know you're in the healthcare field, that a little flag just says, okay, they've got Klinefelters. And he said a lot of times, you know, people you don't have your karyotype done, so you don't really even know until what happens is they're having problems with their wife. They want to have a baby and they can't. So then they go, and that's how they find out sometimes that they have Klinefelters, because there's no major problems medically speaking. And there would be no reason that as a health worker you'd say, oh, I see you have Klinefelters. You know, I mean, even if that flag went off, you wouldn't say it's not related to disease, because who cares, whatever that is. That just gives somebody a whole other set of things to worry about when there's really nothing to worry about. Okay, so the next one, let's just skip on down to Turner since I've got this girl here. Turner's, which is number 12, it says a monosomy X. Mono meaning one. It's only got one chromosome. See where it has XO? It's not that they get an O chromosome. It's that O means the absence of a second one. This is her picture. They're short in stature. They're always going to be a girl. They don't have a Y or the second X. So it's XO. Notice here, they have a kind of like a webbed neck there. They're shorter, low posterior hairline, which means the hair comes down lower on their neck. Now, they have a problem here for some reason. See, this is what's amazing to me. Okay, so they don't get one X. They get one, but not the other. So why do they have all this, like, why does that affect their aorta? Why does that affect their stature? How on earth can all this stuff is due to that one little thing? I guess all the genes are more interconnected than I'm thinking about. You know, because I would think, okay, well, the only thing that's going to happen is whatever's, like, you're missing a few proteins here and there, but obviously not. I mean, this has to do with something about their elbow. See, they are, and they even have this nebby, these little dark spots on their skin. I mean, it goes on. All these things wrong because, let me show you some other stuff there for Turner's. Oh, this is syndrome, Turner's syndrome. Okay. Okay, see the hair down. You can see her webbed neck. Seems like to me too, their ears are lower, and I don't know if it's because their neck is so wide that it just looks like they really are. That's obviously up there. Okay, this says they have an aortic, whatever that is, and a bicuspid aortic valve, and conduction. So that means conduction abnormalities. That means like a problem with the firing, like they may end up having to have a pacemaker or something. I mean, can you believe this? All this stuff, right? All this stuff because of that one thing that happens. Approximately 1 in 200 to 1 in 5,000 live births. That's pretty common, isn't it? We would call that 45, X, meaning they only have 45 chromosomes. And the problem is they're missing an X. That's what that means. Complete or absence, partial absence of the sexual second chromosome. Let me see if I can find you a karyotype thing. I think I'll put a picture here. Here it is. Okay, there it is. See, everything's fine until you get down here and you're missing that second X. So some other things you need to know about Turner syndrome. It's the only known viable monosomy in humans. That means that sometimes they are missing another chromosome, but that baby is not going to survive to be born. So many times whenever there are miscarriages in the first trimester, in the first month or two, the reason is a chromosomal abnormality. And it's just like, this one is viable, meaning you can live with it, but the other ones are so bad and they affect the fetus so much that the baby can't even be born, won't even develop. Okay, it is a female. Those people are female. They are sterile because their sex organs do not mature, but you can provide them with estrogen replacement therapy. And if you do that, then you'll have the secondary, you'll get more girly looking on it. Most have normal intelligence. So if I were to ask you a multiple choice about Turner's, or if I were to give, say, if you have the genotype XO, what is that? Or what would that tell you? And I might say, A, the person is sterile. B, the person has Klinefelters. C, the person has subnormal intelligence, or something like that. And so you see what I'm saying? You have to make sure you know what characteristics. What would go with that I said? Right, you're sterile. Or I might say the only known monosomy and give you that choice, or give you the choice of that, or, are you still doing your vibration? You know.
No.
was gonna say, I'm sorry, we started without you. I'm sorry, okay, good. Okay, so there's some possibilities for Turners. It's pretty interesting. Okay, let's go back to where we were here. Okay, so we talked about Klinefelters, which is XXY. We talked about monosomy X, which means you just have one X, called Turners, produces X over sterile. It is the only known viable monosomy. We also have on your sheet, Klinefelters is XXY. You can also have XYY. If you have XYY, that means there was a non-disjunction in the Y itself. So if you have XYY, are they going to be males or females? They're going to be males. If you have any Ys, typically you would look at the person and say that they're male. Okay, XYY is a male, and they undergo normal sexual development. They tend to be somewhat taller, but other than that, there's really nothing that you can tell. A few years ago, somebody did a study, and they said, wonder if that extra Y makes these guys more aggressive. If that's true, then we would expect that most of the people in prison, like I don't know what percent of people have it walking around, because how would you know it unless you do a karyotype? They would expect that it would be higher in prison than out in the normal population, right? So they went to a prison and they did genetic testing for all the guys, and they said, yeah, there are a lot of guys in prison that have the XYY, so it must be. Because, you know, a lot of times people get in prison because they're like super, can't control themselves, and they're the macho or whatever, which we associate with being more testosterone. Okay, so that was what went along for years, and now they've come back and said, no, that was not they tested other prisons, and they said, no, that was just an abnormal population there, that really doesn't matter, and that you really can't tell the difference. So I was going to say that would be an excuse, you know, but they're saying, no, you can't even use that as an excuse anymore. But you need to know that XYY is male, but XXY, we call that Klinefelter. Do you remember last year or year before, there was a girl in the Olympics, I think it was, and they threw her out. You remember that? Because of genetic testing. I'm thinking that she had XXY, which is Klinefelters, but for some reason she looked like a girl. But they said because she didn't have the same genotype, it wasn't fair for her to be competing against girls. Does anybody remember that?
Yeah.
But I feel sorry for her, actually, because she couldn't compete against guys, because you could tell she was more girl than she was guys. So, you know what I'm saying? She was a good athlete, but they're saying, but is that really fair to let her? I mean, because most of the time, when you're talking about running, guys can run faster than girls. Not all the time, but most of the time, guys have an edge, you know. So they're saying that's not fair for everybody else. It's just like me to compete against somebody that's like got a male chromosome that's giving her that extra. It kind of be like saying she's on steroids or something, but she wasn't. So I don't know. I don't know what the answer to that is, but that's a tough call. All right. Then we talked about. There's also can be. Let me show you. I can show you I can show you what that looks like on a. This doesn't have a name. No, that's not it. We've seen that one. That's Klinefelters. This doesn't have a name that I know of. But wait, what did I do? X? No, I mean XXY. Yeah, 2 X's. Two X's is Klinefelters. That's Klinefelters. Yeah. What did you say, Center?
Yeah. What happened when you talked in
I'll tell you in a minute. I did.
Yeah, when somebody heard the class of first starters, what happened?
Okay, this is XYY. See, everything's normal till you get down here. Pretty cool. So, can you have XXX? So it's a girl that one of the X's doesn't split. So you know, I love looking at these karyotypes. I really do. So in the last class the other day, you were ahead of y'all. And I said, let's see what XXX, if I can get a picture of that. So I just typed in XXX and
Maybe if you say
And then-
XXX.
I'll try that. And so, but I didn't even think about it. And then all of a sudden it says, this information is blocked. I said, why? And then they all start laughing. Sometimes I'm so slow and I'm going, oh, shoot. I guess, and so what was funny is I was telling somebody about it. I said, oh no, what did you show your students? I said, nothing, because Rome State didn't let me. They probably say, we probably have some dumb professors here that are going to do something bad if we let that be. I worry about myself sometimes, just try to, oh yeah, well, triple X, okay, let's look at that. Now, I think that these people, that's it, oh, they're normal looking, there it is, triple X. But there is no, they look normal, I don't believe that. Look, because everything says, let me see what this is. There are many symptoms associated, like really, where is this from? There is no, everything I've read said that you can't tell these people from anybody else. What I say, Claudia's theory is that these are people that are like girly girls, you know, like they like pink and purple a lot, you know, maybe they have to wear glittery glasses, I don't know. That's just what I'm thinking. You know how some girls, like, you know, my daughter likes to hunt and fish and all that, you know. Well, this girl doesn't hunt or fish, you know. I can shoot a gun if I have to, but she has her own sets of guns and stuff that she likes to do. I don't think she's XXX, you know. But that's just my thing. But they look the same and all that kind of stuff. So you need to know that that is possible. Let me ask you this. Could you have Y? Why?
Because I get an X from your mom.
Right, because your mom's getting, all she has to give is an X. So you're getting an X. Now, whether you have one X or two, or whether your X is split apart or don't, all that. But anyway, I thought that was pretty interesting. Okay? The next thing we'll talk about is called, I don't know French, so I'm just going to say create a show. Y'all, if you know that, then just forgive me for butchering it. But let me show you how that sounds. It's called Cry of the Cat. And, oh, I need to do this on YouTube. See, this is what, I'd like to spend a lot of time looking up stuff like this because I think it's so cool. I don't think you want to watch a 7-minute, this is what. Okay, it results from a specific deletion in chromosome 5. Remember how I went through the different types of things? The deletion is something's just left out. These people are severely intellectually disabled just because part of chromosome 5 is missing. Not all of chromosome 5, just part of it. They have a small head with unusual facial features. Their cry sounds like a meowing or mewing or whatever of a distressed cat, and we'll play it for you. Now, your book says they usually die in infancy or early childhood, but from just because I got kind of interested in it, I was looking up. There's like a support group for these people, and there's pictures of people like in their 20s. So I guess that it depends on who you're talking to, how long they live. But let me show you this, the crying cat.
Oh, wait, you need to plug it in.
Or I need to unplug you or something.
Yeah, unplug me on the table. Under your book, I think.
Y'all just unplug it here.
And then you plug it into down there.
Oh. Okay.
Groups and is more common in women by a ratio of 4 to 3.
Let's go back just a minute.
Friedreich-Shaw syndrome, or chromosome 5p deletion syndrome, is a rare genetic disorder
See, you can
that gets
hardly
its
tell
name
the
from the French
difference.
term cat cry. Friedreich-Shaw was founded by Jerome Leguenin in 1963. This disorder affects an estimated 1 in every 50,000 live births. It will strike all ethnic groups and is more common in women by a ratio of 4 to 3. Symptoms of Friedreich-Shaw are a high-pitched cry that sounds like a cat, downward slant eyes, low birth weight, low set ears, intellectual disabilities, including slow motor skills, partial webbing of feet and hands, skin tags in front of ears, small head, small jaw, and wide-set eyes. The cause of Cri-du-Chat is a deletion or problem with the chromosome 5p. In most cases of Cri-du-Chat, the problem occurs during the development of the egg or sperm. In some cases, there was a problem that occurred and the parent passed on a different or rearranged chromosome to their child. There is no treatment for Cri-du-Chat because it is a disorder in which chromosome 5 was deleted. It is recommended that you see a doctor for ways to manage or control the symptoms. And there is also a genetic test that can be done to determine which parent has a change in chromosome 5. Here are some photos of children who have Cri-du-Chat.
See their web page right there? That's unusual, isn't it? See, they were saying they had that little thing after the year, like, what caused that? Just because you got part of number 5 left off? They're showing you here the smaller head. Okay, now let me show you. Let me show you one that has the crime.
I say all that, we never got to hear it cry.
You'll hear it in a second.
Doesn't need to sit there and cry.
Hi, welcome to heaven.
What? Scared me.
What?
I'm not used to being asked if I need help in a grocery store.
Oh.
It's not like
A wide set eyes are obvious, aren't they? Here's another one, let me show you. That's the syndrome. There was another one, it showed the little baby itself. See, I think it would be so interesting to have a whole class on just this.
It's me. My name is Cody, and I'm raising awareness of 5P minus.
So he's got IP minus is what he's calling
Cri-du-Chat.
His name is Joseph. She found out something wrong with Joseph. But we were there 9 days in the hospital. Finally, I got the good mail from, I opened up, I read the name. It tells me nothing, absolutely nothing. I was like, look at this. When I read, I was shocked. It says he will never go walk, he will never go talk, he will be like paralyzed, he was going to be like mentally retarded severely. And I was like, oh my gosh, what is this? I never heard of it. It's a very, very cumbersome disorder.
French for cry of the cat. Cri de chat is a genetic syndrome that occurs when a piece of the short arm of the 5th chromosome is either missing or translocated to another chromosome, and is named for the typical cat-like cry that many newborns with the syndrome have. A variety of physical and mental characteristics are associated with the syndrome, with a wide range of severity and degree of incidence.
Cri de chat often have low birth weight, growth deficiencies, strabismus, palpebral fissures, epithelial folds, microcephaly, and hypotonia. However, later on as they age, they typically become hypertonic, which is referring to high versus low muscle tone. You can recognize Cri de chat by the round face, the broad nasal bridge, the widely spaced eyes, low-set ears, and atypically small jaw. Another interesting symptom is a simian crease in the hands of people with Cri de chat. It's also very
Okay, but just because you have that simian crease doesn't mean you have it, okay? Because, you know, my daughter has that, so my son always says I should not expect much from her. He's just being ugly because she, so just because you have a simian crease, but I guess they all have it, but I mean.
common to have a cleft lip or palate, or improper alignment of the
Like they all don't have the cleft
Cri de
lip.
chat,
'cause you're
end up
so-
having to spend a lot of time in hospital. These frequent and abundant health issues are the reason life expectancy is so low for people with Cri de chat. As was stated earlier, Cri de chat is caused by partial deletion of a varying amount of the short arm of chromosome 5. It seems to happen spontaneously, as the parents usually have normal chromosomes and happens very early in embryonic development. There are several genes that are believed to be a part of the development of this syndrome. Deletion of the telomerase reverse transcriptase gene on 5p13.33 is one of these. Also, the
It's one of those
D-catnase
numbers
gene
is
at
a gene, they know what that
5p15.2
codes
is
for.
thought to be linked to more severe
So
intellectual
just that much right
disability.
there.
More research on these specific gene segments will contribute to finding a cause of Cri de chat.
Okay, does that surprise you that just losing that tiny bit of that one chromosome, you've got the other one, you just don't have both of them, that would cause all those different effects? I mean, y'all see what, I mean, I could sit and I'd look at stuff like this, and I'm not trying to be weird, it's just like fascinating to me that that happens. Okay, so that is Cri de chat. The next one is chronic myelogenous leukemia, CML. You remember we talked about what a translocation is? What happens here, you have, here's a normal chromosome 9, of course these are humans. You have a normal chromosome 22. You have a reciprocal translocation where this part of 9 goes down here to 22, and this part of 22 goes up to 9. Now, the 22, we now call that the Philadelphia chromosome. It's a Philadelphia chromosome. It's a chromosome of 22 that has part of 9 on it. Now, what I said is that this is not the only cause of CML, but it is one cause of it. And of course, any kind of leukemia is a cancer of your white blood cells. So that means you've got way too many white blood cells. When I've, taught this part for 7 or 8 years, whatever, and we go over this and like it's really insignificant to me, like, okay, whatever, we just mentioned it in class. Until 2 years ago, my cousin, who's a little bit older than me, called and said that she was so worried about her daughter, who was late 20s, early 30s. She was just feeling tired. She went to the doctor for a regular checkup, and she didn't hear anything. He didn't really see anything obvious. And the next day was out cutting her grass, so she wasn't sick or anything. She just didn't have a lot of energy. And she was out cutting her grass, and they called and told her husband to have her go to the doctor immediately, right then. So they go tell her to quit cutting grass and go in. And when she goes in, they called her because her routine blood work showed that her white blood count was, I don't remember what it was, if it was like high 100,000s. So immediately when you hear that they've got a white count that high, you know she's got some kind of leukemia. And which was odd because here she goes from out cutting the grass, just feeling a little tired, but obviously she had enough energy to cut the grass, to go into the doctor and they're saying, you're really sick, and if we have to find out what kind this is, or you could die. The best case scenario is that we can treat it, So she lives in Kentucky. She went to Vanderbilt. And so I was telling my son about it, and he said, well, did they say if she has the Philadelphia chromosome or not? And then I'm thinking back, I know what that is. It's that translocation. But he said, that's not the only cause she does have CML. So what they do when they say you do have chronic, which is the better kind, because chronic means it's a slow, you have it for a long time, slow progression. Myelogenous leukemia, if they find, they will test you to see if they can find a Philadelphia chromosome. If you do have the Philadelphia chromosome, that's what's causing it. And that's the best kind. That's, if you have CML, that's good news if they say you do have the Philadelphia chromosome. The reason being is the Philadelphia chromosome was discovered in like the 60s, but like in the 70s or 80s, somebody found, let me go back to the picture. Okay, what they need to do is they need to stop this, this right here. This part is coding for too many white blood cells to be produced. So they have found something that they can give this person that will inhibit, not totally stop, but inhibit expression of that part of the gene. So if you take that and you quit getting this expressed here, then your white blood count goes down. And that's exactly what's happening with my cousin's daughter. They're giving her whatever that is, so that it will stop that expression of that part of the Philadelphia chromosome. And it has made her white numbers go down. But on the bad side, it causes her to, she's had a rash, and, her legs ache. And so there's just like, nothing is free. You know what I'm saying? She's had side effects, but you'll take that over dying. The doctor said he can't cure her, but if she takes her medicine, if she can tolerate the side effects and continue on like that, that she should probably not die of it. So if you have to have some kind of leukemia, and you have to have CML, which is CML is one of the better kinds, if you can say any of them is better, then the next thing you're going to hope for, if they say you have CML, then you just say, I hope I've got the Philadelphia chromosome, because then that's easier for them to treat. So, when you know somebody that's got some of these things or whatever, it's more than just words on the book, isn't it? It's kind of like you kind of get interested in it then. Okay, then the last thing we'll talk about, and we already mentioned this, which was so timely, Anthony, that you sent that article to me. This is talk about inheritance of organelle genes. Because remember we said the mitochondria and chloroplasts, we don't talk about them as much because I'm more interested in us, that our mitochondria has its own set of genes. It's just a little round piece of circular DNA. And that is different from the DNA in our nucleus. And we said that mitochondrial genes, DNA, comes from where? From your mother, and your mother only. All right, so we already talked about that the other day, thanks to the little thing that you gave me. That's just something else. Okay. Now let me see if there's anything else that I need to talk to you all about. I'd like to give you a problem to do and see if you can figure it out. Do y'all have any questions on chapter 12? 15? Yeah. Well, do you have any questions on 12? Actually, all this does kind of go together because we're still talking about meiosis, aren't we? Anybody have questions on 15? Now, for the test, you will have all of the multiple choice, and y'all are going to get all those right. Oh, and also, if you want to come at the 11 o'clock on Monday, you can do that as well. Okay, the cost will be the same to you, don't worry. And that is both, you all and them are both going to be in 118. So whichever time you want to come. So the matching is going to be worth 40 points. Okay, you have got to get those. Okay, because that disappoints me when you don't do that, because I'm telling you on that. And if you have any questions, just look in the back of the book, or they're highlighted in your, or most of them are in the PowerPoints. Make sure you know them. They're going to be 20 matching. Okay, and then with the diseases, which I've tried to tell you what they will be and what you need to know about those. And if you notice on one sheet I handed you out, I said, know how to do Punnett squares, be able to identify the gametes for monohybrid and dihybrid cross, and be able to do blood type problems. Okay, I want to give you a Punnett square to see if you can figure out. How is that? First of all, does anybody have a question about a general simple Punnett square? You just don't understand something about that you'd like for me to. You understand how, in grading your papers that I gave back the other day, I did realize a couple of things that perhaps you don't know. Make sure that when you get, first of all, it's getting gametes. Okay, let's get gametes for this. Let's do this cross. right now, at your seat, write it down. Unless you made 100, if you're one of the ones that made 100 on that test the other day, that quiz, you don't have to do it. But if you don't want your friends staring at you because you made 100 and you're acting too smart, I'd get paper out and start writing. Because we'll know who those people are. So if I were you, I'd be writing. I want to know what the gametes are. Okay, what are they? Remember, in each gamete circle, there's going to be one of each letter. If you've got two of the same letter, whether it's big or little, it doesn't matter. You just have one. So this could end up ending up in the same gamete with that. So let's put that. Or it could end up with that one. Or these two could be together. Or these two. So those are the gametes that we get from that parent. Do y'all agree with that? What gametes can we get from this parent? We can get this, or this. Now we can do, you know what I'm saying, it's going to be the same. So we can do all four, which is going to be two of these and two of these, but it's not really necessary. So now that we have the gametes from the two parents, some of you have problems with this. What do you do with them? You put one set of the gametes on top of the Punnett square. The other ones you put on the other side. Okay, these came from one parent, these came from the other. It doesn't matter if you put the ones from the mother on the bottom of it, doesn't matter. So now, let's do the A's together. Let's keep our letters together. So we have A, then this, and two big B's. Right? Okay, for this one we're going to have big A, big B, little b. Wait, I did something wrong. What did I do? Oh, that's two big B's. For this one, I'm going to have two little A's and two big B's. This one, I'm going to have two little A's and a big and a little. Y'all see where I got those four? So this one, we say big A, little a. Big A, little a. Big B, little b. Big B, little b. Big A, little a. Two littles. Little, little. Big, little. All littles. Okay? So far, so good? So once you've got this, inside the Punnett square, those are your children. Okay? These are the children possibilities. So when I say what's the genotype or what's the phenotype or what percentage of the children, you're looking inside the Punnett square. For this particular one, if I said, what is the genotypic ratio, what you would do is you would say, okay, I'm going to erase some of this just so I'll have room. Do I have any all caps? No. So let's try this one. How many of those do I have? A, B, B. Do I have any more? Okay, so we're just going to put one. Okay, how about this? Do I have more of those? 1, 2. I'm going to erase them as we do them. Okay, let's do this one now. Big A, big A. I think that's the only one for that, isn't it? Okay, then let's go one, this, and then two of these. And one of those. Okay, that's the anytime I ask for the genotypic ratio, there should be letters, not descriptive terms. If I ask for the phenotype or the phenotypic ratio, it's like, if you take a picture of that person, you don't see the letters, do you? What do you see? How they look, tall, short, whatever the color, okay? So I can't really, since I didn't tell you what they stand for, but if you want, we can make up something. Just if we want, we could say that A is dominant over, we know that A is dominant over that. So let's just say, what do we want A to stand for? Whatever. And I hate to pick a thing because, let's say A is brown hair. I will tell you that hair color is much more than this, but let's just say, just for the sake of writing this out, brown hair, blue hair. Maybe we should say eyes. Okay. And like I said, eyes are complicated. So this really isn't a good example, but you just forgive me. And let's say B is brown hair and blonde hair. How's that? And let's say it's a total complete dominance, which is not true, really, because, you know, people have all sorts. There's no such thing as totally brown, and then this one's totally blonde. Usually there's a lot of people in between. But if this were the case, we would say this person had brown eyes and brown hair, as did they. Brown eyes and brown hair. So we would say 3 brown hair, brown eyes. 2, this looks like a brown hair, blue-eyed. 1 brown hair, blue-eyed. 2, 2 blue-eyed. No, these are blonde. Blue-eyed, brown hair. 3 of them. Blue eyes, brown hair. I mean blonde. Well, these are that's blue eyes. That's brown hair. Then to 1 blue-eyed, to 1 blue-eyed blonde. Do you see how this would be the phenotype? Okay, is that good? Okay, I'm not going to give you this one on your test, but on your test it will be like it was before, 2 problems, 2 extras, so that you can make 140. But this is what I did one time. I said, work this problem out, and if you get it, you get 5 points. If you don't get any bonus, okay? Which for some people was good, but for some people thought it was hard, so I'm just going to show you all how to, and like I said, it's not on the thing, but see if you can get it. Okay. I might as well just read it correctly. Anybody need problems with Punnett squares? If you will email me, I'll send you this SpongeBob. And Mary Ann was telling me that if you type it in, that it's online and it's got the answers. So what you can do is take it and then look at the answers and check yourself. These are simple, complete dominance, but then the last page is incomplete. So if you have any problems doing that, all right. This one is like this. Let me find that question. It was actually on a test that I gave.
Claudia, don't forget Cassidy.
What time is it? Oh, 6 after. Okay. Thank you very much, Brandon. Cassidy's got to do an honor project, so we'll do this and then we'll stop. I told you I could do this for a long time, didn't I? Oh, I know. I don't think I stuck it back in. on this one, this was not on the computer and you had to work out everything. It was 2 pages of working out all the stuff and then a page of multiple matching, which was, you can imagine what a pain it was to grade. Then a page on diseases. This was a bonus. In humans, freckles are dominant over the absence of freckles. So let's say freckles or not freckles. Now this is going to be funny what they do. Okay, and wet, sticky earwax is dominant over dry, crumbly earwax. So this is wet, sticky earwax over dry. All right, 2 brothers, one with freckles and wet. Freckles, so let's write that down. Freckles and wet ears. And the other one has no freckles and dry. No freckles and dry. All right, they want to know what the father's phenotypes must have been and his genotype. We know that the mother has no freckles and dry. Okay, so do y'all know how to do that problem? Do you know how to go about it? It's kind of like just solving. You have a bunch of pieces of the puzzle. Let's put it together. First of all, let's see what we know. She has no freckles and dry. What's her genotype? Little f, little f. The only way you can get no freckles is have 2 little f's. And dry, 2 little w's. Okay? This brother has no, like the mom, so he's got 2 little f's and a little w. Freckles and wet. Now there's more than 2 possibilities for him, right? So, he has to be either this, FF, we don't even know the first part, FF, or, well, wait a minute, can he be FF for the freckle part? No. You know why? Because his mother only has an F together, a little f. So he's got to be this. Because if he's freckles, he's got to have a dominant. But because his mom can only give him a little f, we know that's him. Now the wet, we know he's going to get a little w from the mother. So what's he getting from the father? If it's wet, he's got to have a big W, right? So what is the dad? Well, he had to get that from the dad. The dad has to be that. We really can't say, but we know the dad has at least one of those and one of those. So that's as close as I can say. The dad, oh no, he's got to be, you're right. He's got to be heterozygous too. Where the son did that. So this is the dad too. And the dad is freckles and wet. See how you put what you know and go back? Does that make sense? Okay, if you have any questions, please let me know. The people at the Learning Center, I'm sure know how to do Punnett squares. Marianne, are you going to be working with anybody Friday? What time?
About 10 o'clock.
10 o'clock? Okay, if you don't know where they are, if you'll text me, I'll tell you. Now, Cassidy has to come up, or she gets to come up, and she's going to give us a presentation for her honors project.